Are you there, guys?
Good day, good evening, and welcome to today's webinar. My name is Mark Cox, and I'm a senior communicator at INNIO. I'll be your host today. I'd like to welcome you to our webinar platform. You'll notice that this webinar is browser-based, so if you disconnect for any reason, please just click on the link that you received via email to rejoin the session. In order to ask questions, you can send them in via the Questions widget. Just type them into the box at the top left-hand corner of your screen and click Submit. We will allocate some time at the end of the session to address any questions or comments that you may have. Please use the yellow Help widget if you require any assistance, and you can move, resize, and maximize any of the windows in front of you to get a better view of the slides. But now, please allow me to share a short presentation about our company, followed by today's presenters. INNIO is a technology company developing, manufacturing, monitoring, and servicing gas engines for power generation and compression solutions. Our Jenbacher products are specialized in power generation. Jenbacher's North America sales and service hub is headquartered in Houston, Texas. We also have operations in Wisconsin, as well as in Ontario, Canada. INNIO's global headquarters and core innovation center is based in Austria. Out of the more than 3,000 global employees, over 500 highly qualified engineers are focused on innovation. INNIO's Jenbacher business has around 1,700 employees around the world. The first Jenbacher gas engine was manufactured in 1957. In total, Jenbacher's success builds on more than 90 years of engine experience. So far, about 22,000 engines for power generation and CHP have been delivered worldwide. Well over 1,000 of these engines went to customers in North America. Today, INNIO runs manufacturing facilities with a total of 65,000 square meters, producing 5 product lines of high-tech engines with outputs from 200 kilowatts to as high as 10 megawatts. Our engines are known for overall efficiencies of 90% and more. Their durability, fast start capabilities, and the ability to run on a broad range of fuels. Jenbacher also offers a comprehensive set of lifecycle services. Jenbacher has always been a front-runner in the gas engine industry. In addition to a series of world's firsts in technology, business also has a history of growth in the U.S. What started with a small sales and service office in Boston 30 years ago has grown into a strong network of INNIO and distributor sales and service expert teams across the USA and Canada. Jenbacher engines meet our North American customers' needs with top reliability and performance, delivering total efficiencies of up to 95% in cogeneration mode. We offer established, field-tested designs, optimized, robust engine components, along with a proven monitoring and control concept. Our engines can run on natural gas, as well as a broad variety of renewable or waste gases. This makes them a great solution for reducing our customers' CO2 footprint. With the capability to run on hydrogen, the potential to save even more emissions in the future is becoming reality. Our service organization provides everything you need to profitably run your Jenbacher power plant. You choose your tailored level of support, and we will deliver everything from the digital myPlant asset performance management solution for optimized uptime and reduced lifecycle costs, all the way to remote as well as fast on-site service support. We also run a remanufacturing program for efficient overhauls and provide you with comprehensive conversion, modification, and upgrade packages to help you make the most out of your Jenbacher gas engine. Let's look at a few of the most popular Jenbacher solutions for North America. Most Jenbacher power plants run in CHP mode and use up to 40% less primary energy compared to conventional generation of heat and power. We offer innovative microgrid solutions for a stable 24/7 power and heat supply, even if cities face a blackout. With our innovative greenhouse solutions, We power and heat the greenhouses and clean the exhaust gas for use as fertilizer promoting plant growth. Jenbacher-powered data center power plants deliver lower emissions along with fast start capability based on reliable pipeline fuel operation. Using the renewable wastewater gas in Jenbacher engines provides 100% of a sewage plant's energy needs and, in the long run, significant cost savings. With our hydrogen options, we are prepared for a CO2 neutral world, supporting you all the way through this time of transition. By choosing Jenbacher gas engines, you decide for a greener and more profitable future. INNIO, energy solutions, everywhere, every time. And now it's my pleasure to welcome you to this webinar entitled Jenbacher North America Presents Cleaner Power for Grow Houses and Greenhouses with Jenbacher Gas Engines. Today's presenters are Luis Apodita and Gary Farmer. Our webinar today will run for about 1 hour, including about 15 minutes for question and answers. And please make sure to answer the survey questions found in the widget bar at the bottom of your screen, and don't forget to type your questions in. Now I'll hand over to Luis and Gary. Gentlemen.
Thank you, Mark. This is Luis Ampudia, Senior Sales Manager for North America and the Southeast region. I'm your presenter this morning. Thanks for attending. As you know, Jenbacher is a world leader in greenhouse and grow houses for CHP applications. Started back in the 1990s in the Netherlands with the Center of Excellence for Jenbacher, located in Alblasserdam in the Netherlands. We have developed quite an impressive amount of CHP applications, not only in the Netherlands, but all over the world, here in the United States, in Canada, and Mexico. So the greenhouse concept that we have developed from the Center of Excellence, it's by producing electricity for the lights at the greenhouses, creating also the heat in the winter to maintain the right conditions for the best crop production, and also cleaning the exhaust gases to produce CO2, clean CO2 for atmospheric fertilization in a very efficient way to produce electricity with natural gas. The concept relies basically on our engines to produce the electricity in a very efficient way, up to 46% electrical efficiency to power lights, pumps, and fans. And in summer, to generate electricity to sell to the grid. That's mainly for greenhouses. For grow houses, for cannabis grow, is more linear. So in summer, they rely on the electricity to provide cooling. So I will touch base on that one, the differences between the greenhouses and grow houses later on. And as you know, we utilize the exhaust gases for atmospheric fertilization. This is a more diagrammatic, representation of what we do. So we have the fuel gas on the left-hand side coming into the engine. The engine produces electricity on the yellow line, and that is going to produce lighting and for the growth of the produce in the winter, since it is mostly overcast and the lack of sunlight. Also, utilizing the heat from the jacket waters, we will heat up water, and then it will go to a buffer tank. And also the heat from the exhaust gases is recuperated and heat up for water. The buffer tank is utilized in order to keep as a battery the hot water, the heat, and later on pump into the greenhouse, where the heat is dissipated and maintains the temperature ideal for the growth of produce. Also, from the exhaust gases, once they are cooled down and cleaned up in our catalytic converter or SCR, they are pumped into the greenhouse for atmospheric fertilization, where I will later touch base in order to see the advantages of the CO2. Here are some of the differences between greenhouses and grow houses. On the greenhouse, it's usually maintained under glass, and a large portion of the light is through the sunlight, in which also the mother heating is used, mostly heating, very rarely cooling. In the grow house, that is usually utilized for cannabis growing, or in vertical farms, it's inside a building. And most of the photosynthesis needs are met by vertical lights, by artificial light. And in most cases, a lot of cooling is required, especially during the summer months. And in the winter, some heat, since cannabis temperature requirements are less than produce. On the greenhouse, electricity is needed basically in winter and on late hours. And there is a potential to sell in summer. In summer in the United States, it could be used to sell on peaking times when the grid is stressed by high use, and the electricity could be sold for basically for a premium. The electricity used on the greenhouses and vertical farms is basically for light and cooling needs, and is more linear, their use. No need to sell the electricity for the grid unless it could be advantageous. On the greenhouse, basically all the heat from the engine is directed for heating needs, and sometimes is used for cooling, but very rarely. In vertical farms, on cannabis is basically used for cooling, especially during the summer, since the cannabis plant requires fresher temperatures, like in the 18 or 20 degrees Celsius. And in the greenhouse, CO2 is almost all the time used. In greenhouses and vertical farms, this is starting to be used, but not widely. Now, the CHP could provide ways to reduce the greenhouse gases footprint, and also, increase profitability, since it's going to be more profitable to use natural gas, as a source of energy to produce electricity. And also, it's a good way to be a responsible citizen. In order to achieve this, it's good to have most of the thermal energy used. So the thermal footprint could be reduced. I mean, the CO2 footprint could be reduced. And it is also important to work with the local utility in order to help them and to reduce their peak needs, and to explore low carbon fuels such as biogas, renewable natural gas, and hydrogen. Here is a diagram in which you can see where the advantages of using CO2. With normal air, you have like 94% productivity. With the boiler, a boiler, the CO2 can produce up to 110% productivity. And with the engine, we can provide more CO2 and be at 145% productivity. Our system will reduce the NOx. Also, the ethylene is going to be reduced to safe levels below 300% parts per billion. And the CO2 can be used as an atmospheric fertilizer. Also, carbon monoxide is going to be eliminated. As an example, 100 kilowatts of fuel input, that is more or less 241,000 BTUs. In a boiler with an efficiency of 95% can produce 95 kilowatts thermal and 18 kilograms of CO2. With a cogeneration plant with 100 kilowatts of input at 40% efficiency electrical and 50% efficiency thermal, you can produce 50 kilowatts of thermal or heat and 44 kilowatts of electricity. So, by doubling the input of fuel, you can, or 200 kilowatts on the cogeneration plant, you can have almost, well, a little bit more than 95. It's exactly 100 kilowatts and 88 kilowatts of electricity, but 36 kilograms of CO2. That's the big advantage. You can have more CO2 from the engine than from the boiler, and that's a big advantage, and savings on buying CO2. Now, from the economic point of view, assuming $4 per million BTUs on the natural gas, 9 cents per kilowatt hour of electricity, assuming 7 cents of avoidable electricity from the engine, 82,000 hours of operation per year, and assuming heating for 3,200 hours per year and chilling for another 3,200 hours per year, and selling the excess electricity in summer for 4 cents from May to September, you can have more or less a payback of 3.5 years, which is very good. These are basically based on the Northeast rates for gas and electricity. Here's a sample for a greenhouse, and here's from January to May, or maybe October to May, is where most of the heat and light and electricity is needed at the greenhouse. And the opportunity to sell electricity to the grid is from May to late September. To support the local community, the electricity cooling loads versus the absorption chills could be used for the cannabis or vertical farms during May, June, July. So we have about 1,500 Jenbacher CO2 fertilization plants with a total of an electrical output of 2,400 megawatts globally in modular solutions and designed and supported by the Greenhouse Center of Excellence in the Netherlands. With this, I will turn the microphone to my colleague, Gary Palmer.
Thank you, Luis. Before I get started, let me just remind you all that if you do have any questions, use the question widget to input, to type in your questions. We're getting a few, but we can always use more. Either something that you're really interested in learning a bit more about, or if there's a question you were hoping somebody else was going to ask, go ahead and ask it, because we always welcome lots of questions, and at the end of the presentation, we'll provide answers to the questions. And also, don't forget about our survey questions, too. We really appreciate you filling those out, and that really provides us with feedback to let us know how we're doing and how we can tailor future webinars. This one today is the last of our series of 6 for 2021, but we're interested in doing some more next year and subsequent years, so any feedback you can provide us will help us tailor those to make it as valuable as possible to you during your busy schedules. So anyway, so let me go ahead and get started. Luis, you already covered this slide, right?
Yes.
Okay, all right, let me move on to, we talked about the design. Now let's get into the equipment, get into the practical side. We've talked about the concept, but the concept is more than just the engine and the balance of plant, or BOP, as it's referred to. Really, it's the total focus of giving you, the customer, basically a carefree or worry-free application. We'll take care of that. We'll provide as much of the bill of material as is in our agreed-upon scope of work. Therefore, you don't have to put together a system. We'll provide the system as complete as possible. Then it's really the optimal concept is the integration into the greenhouse as well as with the public grid, whether you're still accepting power in from the grid or whether you're exporting surplus power, depending on the application and the site and the contractual situation you have with your local utilities. Maintenance assistance, we have specialized people which will help with the maintenance assistance, greenhouse-specific people with experience, and going across the bottom of the screen, commissioning also by expert greenhouse people. So this is not their, as Luis mentioned before, we have a lot of experience in this field. This is not our first rodeo, so to speak. So part of that is commissioning by experts, service by experts, knowing that construction on site can be very costly. So we try to minimize that, as we show here on the slide, optimal construction on site, meaning as little as is necessary, because it's a lot more expensive for labor, for rigging and so forth on site than it is to do it off site and then bring it in as assembled as possible. And then at the top is high-level project management and supervision, again, by specific greenhouse project managers. So I've got kind of a diagram here showing a lot of components. Now let's look at these individual components. I'm just going to kind of run down the list on the left, starting, excuse me, with the exhaust gas cleaner. Luis mentioned about being able to scrub the exhaust and extract the CO2 for fertilizing the plants. This is part of that, what's shown as number 1. Number 2 is, again, showing the exhaust gas cooler and condenser, again, part of the system of the exhaust, the whole system from the engine to the atmosphere. Oil storage tank, we really haven't talked about that. That's really more on the engine side and is really not specific to greenhouse applications, nor is the, well, the filter box is a little bit dependent on the specific application, in this case, greenhouses and grow houses. The second silencer, item number 6, down here in the lower portion of it. That's in addition to the primary exhaust silencer. The CO2 connection, this is where actually we're piping off the CO2 to pipe it over to the greenhouse grow house. The control panels, in this case, this is an external enclosure, and we have our control panels on the exterior of the building so that readily accessible. And let me see, next it would be the connection to the heating and gas. This is really just showing the supply and return locations for the heating water and the input for the gas. And as always, sound is an issue. Every process involved with a mechanical device like an engine produces sound. So we're really tough on keeping sound as quietly as possible. Not all greenhouses and grow houses are out in rural areas where you have a lot of free air. Sometimes they are in congested areas like residential. There's sometimes when warehouses are being repurposed into vertical grow houses. In that case, you may have residential neighbors. So sound could really be an issue and could be very difficult when it comes to permitting. So in this case, we're really keeping the sound levels down. 10, 11, and 12 on the screen, you'll show the exhaust stack. We're trying to keep that at 70 dBA at 1 meter, which is pretty strict. The ventilation ducts, numbers 11, those are actually the exhaust, actually the ventilation, I shouldn't say exhaust because they're drawing air through and across the generator to keep that cool and then exhausting it into the atmosphere. But again, those fans create sound. So we're attenuating that sound as much as possible. And then overall, number 12 is the acoustical enclosure. And we can make that to whatever site requirements are necessary. In this case, we're actually showing, again, 75 dBA at 1 meter, which is a pretty strict level. Now, speaking of the system, the generator itself, shown here in the green in the center of the screen, is really the hub around which the overall system spokes radiate. So I'm going to start down in the lower left-hand corner. We're showing the typical electric utility, shown by the aerial transmission lines. The mains are coming into the box immediately to its right, showing the grid connection circuit breaker, controls of that breaker, any type of utility metering that's required by the local utility, and any type of regulations, both in devices and their functions. So that's connected. That's one spoke leading up to the generator, going around clockwise around the hub. Next is the gas train control and mixing. In this case, we're showing 2 gas trains, which would indicate that there's a gas mixing. In this case, it could be natural gas and propane, natural gas and biogas. So it could either be a blended gas, or it could be a selectable, one gas or the other, again, depending on the site. Continuing around, we're looking at the exhaust gas treatment. This Luis mentioned earlier about SCRs and oxidation catalysts wherever necessary. Continuing the heat recovery, these are the exhaust, these are the heat exchangers, as well as sometimes dump radiators. If there's not enough usage for the hot water, we can exhaust that, dump it into the atmosphere if necessary. Down to immediately below that is the module control panel. This controls not only the engine itself, but also the pump systems for the heating and cooling water, any valving associated with it. And on that control panel, you see a kind of a rectangle, and then off to the right, I'm going to show a little larger screen of that. That's the customized plant control. This shows nice schematics. You can flip between different screens, showing schematics of individual systems, overall systems, operating temperatures, performance parameters, and so forth. This can be customized to your needs. Continuing around the different bus systems and interface connections, this is multiple protocols that we can provide depending on what is there or what the customer's preference is. Continuing around, we're looking at the myPlant connectivity. This is showing a smartphone being used for remote monitoring, and I'm going to show a little bit more about myPlant in just a moment. And then finally at the bottom, the mains operator, interfaces, and power and reactive power. This is the overall control provided in the module control panel. So this is really providing overall system control. So it's more than just the equipment. We're really tying in all of this so that the end user can really work together with all the environment around him, with the utilities, both gas and electric, as well as atmospheric in the engines and so forth. So this really provides really a symphony of coordinated operations. Here's a little bit more about the myPlant. We're seeing this provides 24 hours a day, 7 days a week, remote monitoring, diagnostics, and analytics. This really helps to reduce unplanned downtime. Has trending functions where you can see not only snapshots of what is happening at that time, but also look into the past as to what has happened in the past, and then lay out some trend analysis and hopefully trigger any unplanned maintenance that basically shut the system down and do whatever maintenance is necessary prior to any large-scale issues. Down in the lower left, you see where, using avoided costs, for example, shutdown times for 6 to 8 weeks, if it was a catastrophic issue on a 3.3 megawatt engine, could trigger a shortfall of $160,000, depending on a lot of assumptions, including the feed-in tariffs and downtime. So this system is very user-friendly, but it can also save a lot of money when it's used. Continuing on, now we're actually going to look at some systems. We're going to see some photos, and then we're going to also see some design drawings to really help you visualize what these types of systems are. Acoustical enclosures can be either indoor or outdoor. Most people think of enclosures as strictly outdoor applications, but there are times, as shown on the larger photo here, this is an indoor enclosure where it's really used primarily for sound attenuation. So it's really no weatherproof aspect involved in it, much like unlike the outdoor enclosures. But a lot of the components are similar. In this particular case, you see the box just to the left of the black door in the near field. That's actually the control panel. You can see the little rectangle there, the HMI control screen. And then off to the far right of that same photo, you see some of the exhaust systems. And then the two photos to the far right are outdoor enclosures, similar to the indoor enclosure, but they have the weatherproof aspects, obviously, including the ventilation hoods on the top of the enclosure. Now we're going to look at some drawings of these. On the left, again, we're going to show the indoor enclosures. The top view is showing the top or plan view. We're actually showing two generators side by side within the same room. The exhaust systems coming off the engines, going down the center, and then going into the exhaust cleaning, silencers, any type of oxidation catalyst or SCRs as necessary, any basically treatments. And then the CO2 offtake would be there, and then ultimately there'd be a vertical stack for the exhaust system to admit the exhaust gases into the atmosphere. And let's see, on the right-hand side, we're showing an outdoor enclosure, a little bit different arrangement, more of a U-shaped arrangement where the engine is right down the center going vertically, and then the exhaust is going off to the left a little bit and curling around in a U-shape, and then the exhaust system, cleanup, SCRs, CO2 takeoff, and silence is all on that side. And up on the upper right-hand corner of that, we're showing like urea tanks, oil reserve tanks, and some of the other ancillary items, as well as, again, the control systems on the exterior. Well, in this case, we're actually showing the interior. It's a walk-in type enclosure, so we do have auxiliary as well as control cabinets inside a walk-in aisle. Let's see, a P&ID diagram, typical, they're a little dense. So rather than try and show a lot of this, I'm just going to kind of give you a quick rundown from the top to the bottom, going across, basically referring to the upper horizontal line. That is going to be the water return. Below that is the water supply going out. This is with the water return, the supply and return coming from the engine. Stepping down from there, the third horizontal line is really the exhaust systems, showing the filters, the exhaust systems, the exhaust heat recovery systems, the CO2 takeoff, and continuing on down, then we're getting into some more of the water supply and return. So this is really showing all of the mechanical systems involved. And I would welcome you A lot of what we're showing you today has a lot of facts and figures on it. I would welcome you to take a look at these at your leisure, because these presentations will be available on demand after today's presentation. So you can take them and take a look at them a little bit closer then. Again, showing a orthographic drawing in there, as well as a little isometric drawing on the far right-hand side. At the top, we're showing the plan view or above view, showing the engine and the exhaust system below that. And then below that overall is the elevation of the outdoor enclosure, showing the ventilation stacks very prominent there, as well as the exhaust stack rising above the ventilation stack to make sure its dispersion is proper. And then the isometric drawing there on the far right kind of shows the overall layout. Really, it helps lay out the exhaust system for you as you see it coming out horizontally and then curling around, and then ultimately going out through the vertical stack. Lifecycle services. We're currently servicing over 48,000 gas engines worldwide. I mentioned earlier, and Louis mentioned too, that this is not, we are not new to this business. With 48,000 gas engines out there, we've got a lot of experience doing this, to put it mildly, both using the remote monitoring as well as the hands-on service aspects of it. This is something we really stress, particularly with these engines running continuously. Service is utmost and vitally critical in order to maintain their operation and really extend their life for many, many, many years. Continuing on, just some rules of thumb, and again, don't write these down. Take a look at this presentation a little bit later on. Heat demand. In the northern U.S. as well as all of Canada, we're really looking at approximately 500 kilowatts per hectare of greenhouse. Heat demand in the southern half of the U.S. and Mexico, approximately 350 kilowatts of electricity per hectare. The electricity demand for lighting is about 1 megawatt per hectare per 10,000 lux of lights, and the temperature increase due to 1,000 lux is approximately 0.7 degrees Celsius. So as you can see, these all interact with each other. Let's see, moving on down, the CO demand, this is critical for greenhouses. For vegetables, the carbon dioxide demand is approximately 250 to 300 kilograms per hectare per hour, while for flowers, the range is between 75 and 175 kilograms per hectare per hour. And finally, for a SCR system, urea consumption is approximately 2.5 liters per megawatt hours. So these are all good rules of thumbs to keep in mind when you're doing some initial layout, or just kind of a proof of concept when you're first thinking about doing a project. Mentioned earlier, and I know Louis also mentioned about the international installations that we have for greenhouses and grow houses. More than 20 countries, 1,320 installed units in greenhouses. 60% of them, interestingly enough, have the carbon dioxide fertilization. And these range anywhere from 635 kilowatts for a single unit up to 26 megawatts. And we're actually going to go through a number of these installations and just show you the size and the scope of some of them. So we're going to start in the Netherlands, where we have this project, the Royal Pride. As you can see, we're looking at 14.6 hectares, 3 units of that size, or 3 greenhouses of that size. The power plants consist of 2 plants, 1 and 2. Boiler systems, you can kind of read down through it. The boiler system, the CHP, 6 units of 3 megawatts each, and then a buffer of 5,000 cubic meters of hot water. Energy plant 2, we're looking at 6 3-megawatt units, as well as another 2 4-megawatt units, and then also a buffer of that same size. Continuing on, in Canada and the USA, the Great Northern, this is in Leamington, Ontario, just outside of Detroit a little bit on the Canadian side. So we're looking at 12 megawatts there. Howling in California near LA, 13.2 megawatts. Hoosier Energy in Indianapolis at 13.2. Another Howling unit there in Vancouver at 8.8. And finally, for the US and Canada, is Coldwater, Michigan at 13.8 megawatts. So these are the systems that we already have installed and are in our operation, and we have others that are in process. Looking into Belgium, in this case, you can see this is a very large unit, total of 45 megawatts being delivered by 12 individual generators. So this is a substantial size greenhouse. Continuing on, Russia has been a very hot market lately for greenhouses. If you look at this screen, we've got 3, 6, 9, 12 installations. Just in Moscow is nearly 50 megawatts. So this has really been a high growth area in greenhouses and grow houses. And finally, in the UK, we're looking at 5 units here, various sizes, various locations. So again, this is not something that's isolated to a particular part of the world. As you can see, there's a lot of work that we've done in the past internationally, as well as domestically in the US and Canada and Mexico. So at that point, we're pretty much finished our presentation, and we're going to move into the question and answer session. So I'll go ahead and thank you for listening to us, and I certainly am interested in seeing your questions, and Lewis will join me, and we'll start putting together some answers for you.
Well, great. Thank you, Lewis and Gary, for your presentations, and thanks to all of the attendees for your attention as well. And as Gary mentioned, we'll now move into Q&A. If you have questions, there's definitely time to enter them into the questions widget, so please do so. Before we begin, I'd like to ask you once again to complete the survey, which is also found in the widget bar at the bottom of your screen. That'll help us to know how you're finding the webinar so far and how we can improve for the future. If you'd like to have us get in touch with you right away, there are a number of ways to do so. You can either let us know in the chat or via the Contact Us widget, which is also on the screen. You can also, of course, fill out a form at either www.jenbacher.com/America or www.INNIO.com. And as a reminder, today's presentation will be available on demand in just a few hours, so please just follow the link you received earlier if you'd like to see and hear the presentation again. With that, let's look at a few questions. The first question is, with the push for RNG in the market, what effect does that have on greenhouses? Or better said, what effect does RNG in the market have on greenhouses? Gary, Lewis, I'd like to answer that.
That's a good question and very timely. RNG has really been a subject that's really been coming up in the near past, and is getting a lot of interest across the business. And with the push for RNG, obviously it's going to be heavily dependent on what you're able to get for your RNG, whatever the subsidies are. If subsidies are not that great, where it's really not worth you just taking your RNG and then depositing it into the existing pipeline for natural gas. Obviously, you can put a CHP unit there and produce your own electricity, hot water, CO2, etc. And that's a whole different aspect to just what you can get paid for RNG. Also, if you are still doing RNG, or if it is attractive enough, but you're limited as to how much RNG you can inject into the pipeline, if you have something left over, again, you can use that rather than selling it as RNG. You can take that gas that's been cleaned up and put it through a smaller CHP unit to, again, take care of your on-site production. So RNG is not necessarily negating CHP. It's really it may be reducing the capacities of CHP, but the two can work side by side.
Okay, super. Thank you, Gary. The next question, I believe you touched on briefly. Maybe you can give a little bit more background. With supply chain slowdowns driving vertical grow houses being installed in cities more and more, are there any noise or footprint concerns around the Jenbachers?
Well, yeah, with supply chain issues, yeah, obviously, the closer to your market where you can grow product, the better. You're not having to ship it across the country, which luckily in the U.S. and Canada, we have a bit of a luxury with shipping capabilities. However, with the trucking industry, what it is now, it has gotten a little bit more difficult. So growing product closer to the market is advantageous. Reutilization of existing buildings, I think I touched on this earlier, of let's say existing warehouses or office buildings, into converting them into grow houses or really grow houses in some fashion. If they are adjacent to other industries, that's usually not a problem as far as ambient sound and so forth, or ambient conditions. But if it is nearby, let's say it was an office building that's being repurposed, and there's residences around it, sound levels are critical. As I showed earlier on a couple of the slides, the greenhouse type application is really well suited to that, with lower sound levels than a typical diesel standby or some other on-site power generation. It's quieter than other types of on-site power generation technologies. Louis, did you have anything to add to that?
Well, just to mention that we can go as low as 55 decibels at 10 meters from the battery limit. So that is less than your AC unit outside your house. So they are very quiet.
Good point.
Okay. Thanks, gentlemen. Remember that you can still ask questions. Just use the questions widget in front of you, and we will get back to you, if not today, then via email. The next question I have here, can Jenbacher help me with feasibility studies, specifically around selling power to the grid profitably? I am in California. Interesting question.
Well, we definitely can help making a business case and start the ball rolling in that sense. We can give you general directions and at no cost. But if you are really thinking about millions of dollars investment, we can give you or provide. We can provide a general business case for a bank's application or something more than that. Well, that would be a little bit out of our range. What do you think, Gary?
That's usually, yeah, and I've done that in the past. I can give them some, some general guidelines for them to help make their decisions, or at least decide. You get to the various stages along the project development. In fact, I just did one yesterday where I was helping a client take a look at some systems. And they were very interested in see, they had no real concept as to what the costs associated with not only the capital expenses, but also the maintenance expenses and operating expenses. So I was able to help them kind of flesh that out. And they were then able to provide some of their own costs by looking at their utility bills and so forth to really help them build the case for doing a CHP plant at this facility.
Okay, super. Thanks, gentlemen. Let's see, we have at least one more here. what does myPlant cost? Is it a subscription or is it based on use? Gary, you were talking about myPlant.
Yeah, it's a subscription based purchase.
There you go. Quite simple.
To put it bluntly, yeah.
Great. And let's see, we've got one more. So if anyone has a question there, please type it in now. We've got one more here. It's pretty general. It's just, could you please talk a little bit about Jenbacher's team in North America? And do you have local support, or does everything come from Austria? Maybe this is regarding our partners.
Mm-hmm. Exactly. And we do have local support. In certain areas of the U.S. and Canada, well, in the U.S. we have direct Jenbacher employees. This is in our direct territories, and the other in other territories it's being handled by our partners, our distributors. Some people would call them. They handle sales in that area as well as service in their designated areas. So yes, we do have local support. People are not coming from Austria. So yeah, we do have people on the ground here in the U.S. and Canada.
Okay, super. And a little bit further to that, a question regarding financing or leasing. Is it possible?
Generally speaking, we are strictly in the sales end of it. We don't really get into financing and leasing. That's not to say that's not a hard no, but it's something that can be discussed. But I think a lot of people still can. We previously had this under when we were owned by another company, an outside company. We had that as an option. With the direct sales, no, we do not have that option. However, through some of our partners and distributors, yes, that could be something that they could handle or offer if that were come up into it. I do see we have another question just came in. I was going to bring this up, actually. Go ahead.
Yeah, sure. The question is, with the marijuana business being an upward climb at the moment, does Jenbacher intend to tap into that market?
Short answer is yes.
Yeah. Yep. There you go.
Yes, and in fact, I was going to bring up during our discussion, during our presentation, and with cannabis has become a very, as the question says, upward climb. It's become very popular, particularly in the U.S. as more and more states are legalizing it. There are different load levels or different electrical loads, and Louis, I'll ask you to join in here. On the marijuana load, what would be a typical, again, rule of thumb, what would be a typical load for a hectare of marijuana?
Per hectare, depending where you are, but the southerner you are, the more you're going to spend electricity on cooling. So it varies from 4 to 10 megawatts per hectare, more or less, because the lights are always on, especially if the company is doing medical cannabis. Mm-hmm. Yeah, it could go up to 10 megawatts per hectare, or 2.5 acres. So that's the rule of thumb, but it varies from 4 to 10 megawatts.
Okay.
Okay, great. Hopefully that has answered the question. Is an additional question has come in regarding mobile Jenbacher engines. I think this is in regards to containerized units. Does Jenbacher offer them?
Yes, we do. We have several containers, and they are semi-mobile, containerized, especially in the lower capacities from 1 megawatt to 1.5 megawatts. They are quite maneuverable, and we're working on 1 megawatt, very mobile for rental purposes that may be coming next year.
Okay, super.
Do you have anything to add, Gary?
No, that pretty much fills it. I mean, I have worked with clients who are interested in looking at mobile units, and mobile not in the traditional sense as being on a flatbed trailer, but mobile, and that they would have it installed at one site, and then if that site had to be changed, or could those units be disassembled and then transported to another site and reinstalled? And yes, that is also possible. So that's not the traditional idea of a mobile unit, but yes, it can be. Again, it's on the smaller units where that would be a feasible application.
Excellent. Yeah, I think the answer is yes. There are containerized mobile units. We also have very capable partners that are offering solutions, right?
Exactly right, and Mark, and that's a good point. There are some things that our partners can offer that we, as the factory, don't offer as a factory type of product, but our partners can certainly have other things. And I suggest you check with them to see what their capabilities are and what they have to offer, not only in the genset, but also in electrical switchgear and other technologies that can be working with the genset itself to provide an entire system.
Exactly.
Yes, and in the direct territory, we are working very close with AB Energy for the greenhouse applications and cannabis applications.
Perfect. All right, so the best thing is just to get in touch with either us or AB directly, and we'll find a solution that's going to work for you.
That is correct.
Okay, we have just a few more minutes. An additional question has come in. What is the higher level of hydrogen it's possible to mix into feeding gas? A little bit of a different question. What is the highest level of hydrogen that's possible to mix into feed gas, I believe is what's intended here. I'm paraphrasing.
Okay. It varies depending on the model of genset. All of our gensets are capable of using up to 25% hydrogen.
With no duration.
Yeah. We do have one unit, our 420 unit that is capable of operating under 100% hydrogen. So that's approximately a 1 megawatt size.
Right. Yeah, 0.9 exactly.
Yeah, that's our current status. We are working on increasing the capabilities of the hydrogen capabilities of all of our product line. So stay tuned.
Right.
And one thing that could be done is to have an engine that is 25% capable, and then if needed be, it could be refurbished to 100%.
Correct. Yep.
In the future, right?
Yep. And a key part of that would be that conversion could be taking place during a planned major maintenance interval. So therefore, you're going to minimize any downtime by doing that conversion when you're already planning on doing a major maintenance overhaul.
Yeah, that's right. So companies looking to possibly use hydrogen in the future can purchase a natural gas engine today, and rest assured that it'll be able to handle hydrogen when it becomes more available in a few years.
That's a very good point. Yeah, and we're certainly not unique in that situation. Hydrogen is becoming a big subject, and capabilities of engines with it right now are lacking overall. But everyone's pushing in that direction to increase the not only the availability of hydrogen, but also the capabilities of the engine to use the hydrogen. When I say not only the availability, but that includes the gas pipelines and so forth. So yeah, getting hydrogen to the sites is a challenge. That's kind of out of our hands, but once it gets to the sites, we can use it.
There we go. Great. Well, with that, we have reached the end of today.
Hello?
Hi, and so with that just leaves us to thank Jenbacher INNIO for sponsoring this presentation, and to Gary, Lewis, and Mark for what has been a great discussion. You can find the on-demand version of this webinar on our website, www.pmi-live.com, and you'll also get an email saying, giving you a link as well to that on-demand session. So on behalf of everyone, thank you very much for watching, and we hope you have a good rest of your day.